Good afternoon from India to everyone joining me from different time zones. Thank you, sir, for introducing me. I am very happy that I got this opportunity and be a part of this conference. It is a great pleasure to present my work at the second International E-Conference on Geological and Environmental Sustainability at the United Kingdom. This slide shows the important areas that I will be covering as I walk you through my presentation. I will first talk about objective of my work, selection of a study area, followed by sources, exposure, and health of arsenic and its impact. Then I will talk about permissible level of arsenic and the level we found in our study area. Then I will describe the methodology and walk you through the experimental design, results, and key finding. I will present my slide one by one here. Let's start with the objective of my work. The key objective includes to assess groundwater quality in an industrial area, to identify key contaminants and their sources, to determine concentration of the contaminants. One of the primary objectives was to develop a low-cost method for removal of the key contaminants. And finally, to recommend steps to mitigate contamination and protect the people for the further exposure. This slide is described the selection of the study area. I hope you are able to see the slide. Okay. I would like to make you all familiar with the small town named Sirgitti, which is approximately at 5-kilometer distance from my hometown, Bilaspur in Chhattisgarh. Basically, this place is known for its various industries located around the town. That's why I decided to select this area for my research. I have done a lot of work in this area on other aspects of environmental pollution. But for this study, I wanted to focus specifically on arsenic contamination and its removal from the drinking water in vicinity of my study area. Because local peoples depends on the groundwater resources and its drinking, cooking, and bathing and irrigation and some other domestic purpose. In this map of India, I want to show you my study area in this slide. We can see the region affected and non-affected by arsenic contamination in groundwater. But Chhattisgarh region is moderately affected. Let's proceed with anthropogenic and natural sources of groundwater contamination. Here, I want to highlight a few problems in my study area such as poor drainage system, improper septic tank, which resulted in contamination of groundwater by sewage microorganisms, and some other factors like industrial effluents, acid mine drainage, sewage, and landfill leachates all have also contributed to contamination of local groundwater with iron and manganese. Since my presentation focuses on arsenic, I would like to highlight that the major source of arsenic contamination in groundwater is geogenic. Arsenic has atomic number 33 and is classified as metalloid. It is 53rd most abundant elements in the earth crust. It is associated with igneous and sedimentary rocks. It is also called king of poison and poison of kings because of its potency and its historical use of murdering people of power. Its toxicity associated with its solubility and depends on pH. For example, arsenite, that means trivalent arsenic, is more soluble and toxic than pentavalent arsenic, that means arsenate, which is the less soluble. Coming to the next slide, which is mainly about arsenic and how it contaminates food and water. Humans are mainly exposed to arsenic through drinking water and food. Arsenic affects different parts of the human body. As you can see here in this figure, it affects the nervous system, it affects the cardiovascular system, renal system, skin, and endocrine system, and respiratory system also. Chronic exposure of arsenic through drinking water can lead to several health problems such as arsenicosis, skin lesion, hyperkeratosis, vitiligo, melanosis, skin cancer, and cancer of internal organ, and exposure in pregnant women and infant is linked to negative impact on cognitive development and increased death in young adults. This slide shows the skin lesion caused due to the exposure of arsenic. This can lead to skin cancer. These slides present the permissible limits of arsenic according to World Health Organization. World Health Organization has prescribed a provisional guideline value of 10 microgram per liter or 10 parts per billion of arsenic in drinking water. So let's take care of this important level and the safe limit in drinking water. Coming to specifically in my research area, the arsenic levels were experimentally found to be around 50 to 90 microgram per liter. Many researchers reported in their work and invented some new technologies for removal of arsenic, such as oxidation process, coagulation, flocculation process, and ion exchange, membrane technology, and adsorption-based techniques also. Let's understand in deep about our method, which is based on oxidation, coagulation, adsorption at optimized pH using sodium bicarbonate, potassium permanganate, and FeCl3 as pH conditioner, oxidant, and coagulant, respectively. It is an efficient and low-cost method for removal of arsenic from groundwater. Our methodology used three important treatment process. First is mild alkaline pH conditioning by sodium bicarbonate and oxidation of arsenite and ferrous ions by potassium permanganate itself precipitating as insoluble manganese dioxide under the pH conditions. And third one is coagulation by FeCl3. FeCl3 has been used for removal of arsenic ion from water. This is a quick slide where I wanted you to see the typical hand pump commonly used in rural India for assessing groundwater. In this slide, we can see the low-cost arsenic removal apparatus. We have performed this experiment in our lab. It has turned out to be time-taking, but very cost-effective. The reason being, we have used sodium bicarbonate solution to optimize pH level. After that, by using different concentration of potassium permanganate and FeCl3, we have prepared a fixed dose. Now, this fixed dose of FeCl3, KMnO4, and sodium bicarbonate and contaminated water sample was kept in the coagulation chamber. And after that mixing of the solution with glass rod led to precipitation and then the formation of coagulant. Gentle stirring water during dosing resulted in coagulation and precipitation. Sample that were filtered with Wattman 42 filter paper and filtrate were stored for analysis. So at least all the impurities and fine suspended particles get adsorbed on the surface. This could be separated by the process of filtration in which the water sample is kept in filtration chamber to remove arsenic. This slide shows experimental steps. Here we carried out our reduction of pentavalent arsenic to trivalent arsenic before the determination of the total arsenic, and a series of coagulation adsorption experiment were performed on water sample. It is a very busy slide, and pH adjusted in the range of 7 to 7.3, which is a favorable range for arsenic removal. This slide summarized our key results. We found that increasing coagulant dose, that means FeCl3, resulted in higher efficiency of removal of arsenic due to the increases in flocculation. Optimum pH was found to be 7.3 for the removal of arsenic. At high acidic and high alkaline pH, the effect of coagulant was noticeably reduced. Since Pentavalent arsenic and trivalent arsenic anions are soluble. Adding FeCl3 as a coagulant converts them into insoluble product which are easily removed in coagulation and the precipitation process. Arsenic removal efficiency of 95% or higher are achieved for initial arsenic concentration, bringing it down to 2 to 4 microgram per liter arsenic level. We observed that at increasing dose of oxidant KMnO4, the removal of arsenic also increased. Similarly, during addition of increasing dose of coagulant, that means FeCl3, a similar trend was observed. You can also note that when KMnO4 was added oxidant, the concentration of bicarbonate and FeCl3 were kept constant. When FeCl3 was used as coagulant, the concentration of bicarbonate and KMnO4 was kept constant. And you can see here the third graph shows the arsenic removal is lower at higher and lower pH, but the optimum around 7.3 pH. You can observe we were able to achieve more than 95% arsenic removal efficiency using our method. The arsenic level were much below the WHO permissible limits and safe for consumption. In conclusion, I would like to mention that our low-cost methodology based on oxidation coagulation process was found to be efficient at making the drinking water safe for human consumptions and domestic use. This concludes my technical slides. Next, I would like to express my thanks to all those that helped me make this project a huge success. Firstly, I would like to sincerely acknowledge my team members, without whose untiring efforts this work would have been impossible. Secondly, I take this opportunity to thank my principal, management committee, and my colleagues for my parent institution, DP Vipra College, Bilaspur, that has constantly encouraged me in my research effort and provided much needed support. Last but not least, I would like to thanks the local people on site for their cooperation in all aspects. This is the laboratory of the Department of Chemistry in DP Vipra College. Here, a lot of instruments like double beam, ultraviolet, water analyzer kit. You can see here the right side water analyzer kit, and so many good instruments are here for the research purpose. A nice quotes from the Rig Vedas. I would like to leave you with a profound message from Rig Vedas, which is one of our ancient scriptures. With this, I conclude my presentation. I thank you for your patience and kind attention. I will be happy to take a few questions. Feel free to reach out to me via email and chat box and meeting. Good luck and stay safe. Thank you so much.